Welcome to another PyPhysicsSandbox tutorial video. In this one we're going to look at some of the miscellaneous things that you can do with shapes once you have them created, some of the properties and methods on shapes. So we're going to start with a ball. Now we've already seen that you can set the color on them, so that's one of the properties that you can set. And I'm going to create a floor. This should be familiar if you've seen some of the other screencasts. And I'm going to run this just to show what happens with the defaults. Okay, the ball is going to fall down on the floor. It'll bounce. The bounciness of the ball and the bounciness of the floor, this is the default behavior. Now, we can change that. We can set, for example, the ball elasticity to be something different than the default. So if I set it to 0, for example, now the ball just plops down. It has no bounciness at all. If I set it to some high number, then it bounces way up. In fact, it bounces farther up each time than it did the time before. So in general, you want something less than 1.0 for this. The default, I believe, is 0.6. So if I do for example, a 0.9 here, bounces up about 90% of the way. If I do a 0.1 here, doesn't bounce up much at all there. So you can play with this value to get the elasticity that you want. Now for the next thing, I want to set this to not bounce at all, and I want to look at hitting the ball. So programmatically hitting the ball. So I need to add an observer function for this. And let me go ahead and define this. Now remember, every observer function takes the keys that have been pressed. In this case, though, I'm going to use mouse clicked. And I'm going to call the hit method on the ball itself. And what that takes is the vector, the force vector that I want to use to hit it with. So in this case, I'm going to use 0 in the x direction. So it's just going to hit it in the vertical direction. And I'm going to use negative 400,000 in the y direction. Then I have to say where I want to, on the ball I want to hit it. And in this case, I'm just going to use the center point of the ball. So if I run this, it drops down. If I click it, bounces up a little bit. If I keep clicking it, I can keep hitting it up. And then it comes back down. So what you need to put in for the force here depends entirely on the mass of your ball, on your mass of your shape. And in my case, my ball has a default mass based on its area. If I put in, for example, a mass of 10, that's going to be much lower than the default. When I click, it just got hit way up, and it probably won't come down for a long time. So the force here needs to depend on the mass of your object, and that's just trial and error, figuring out what gives you the effect that you want. Okay, I want to look at another element too. So I'm going to use some key presses here. So if the right arrow key is pressed, I'm going to set on the floor the surface velocity property, and I'm going to set it to 100, 0. So that's 100 in the x direction, so that's to the right, and 0 in the y direction. And if the left key is pressed, I'm going to set the surface velocity equal to negative 100, 0. and go ahead and run that. So this is clearly a live screencast. I got an error here because I did not name my variable the same as what I was using in my method. I'll go ahead and run this again. So now I'm going to press the right arrow key. The ball starts getting taken to the right. So basically the surface velocity, and that's the left arrow key, sets up a conveyor-like behavior for the shape. So the floor, having a surface velocity to the right, carries any object on it to the right. Surface velocity to the left carries any object on it to the left. So you can play around with that to get the conveyor belt-like behavior. And I've still got the click in there too. So you can combine these different things in order to get the effect that you want. Okay, so there's one last thing I want to talk about. So normally, if you create overlapping objects, the physics engine will try to make them not overlapping as quickly as possible. We'll try and push them apart from each other. So I've created my text here in the same area as my ball. So let me temporarily here set the gravity to nothing so that we can see what happens. So that text then is kind of pushed away, and in this case the upper left corner kind of point of the text is outside, so it feels like it's far enough away for the physics engine to stop pushing it. It was originally right in the middle. In order to prevent that sort of behavior, there's two things that you have to do. You can set the group of the two shapes equal to the same number. So my ball group and my text group can both be set to 1. And the number here doesn't matter, they just have to be the same number. And any two shapes with the same group then do not collide. They don't interact. They're considered to be essentially the same sort of object, so they don't interact. Now if I turn on gravity, I can see that they don't interact, but they're also both interacting with physics in different ways. They're unique objects. So the last thing is I can do a paste on and tell the text, you're pasted onto the ball. So not only do you not interact with the ball, but you're pasted onto that ball. You will follow that ball around wherever it goes. So let's see the effect of that. So now the text and the ball are joined. As the ball turns, the text also turns, and it remains in the same relative position with respect to the ball. So those are a few of the things that you can do with the shape methods and properties.